Tonight's demo is one of our demonstrators, is one of our own members, Dan Swaim. And Dan, where do you live at? Fort Collins. So another local turner as well. And I'm going to let him tell us about himself and about what he's going to turn for us tonight. And I look forward to this awesome demo.
We'll have to check on awesome or not. Well, I'm Dan, and I put my contact information up here, both phone and email. And I'm happy to, I'm listed in the club as a mentor for segmented turning. And if anybody ever wants to come by either my place or me coming to your place or get on FaceTime or any of those things like that, ask questions, feel free. That's why I put the contact information up there. I'm a retired engineer, and not much of an engineer, but no other profession I could claim to, so that's the one I'll do. And it turns out that I'm much more of a constructor and a builder than I am a turner. So as we go through this thing, it's always good to get your excuses in early. So I'm pretty good on building and constructing, not a maestro on turning. You're going to get a lot more like a harmonica job than a symphony here as we go through this. But I've only been turning since about 2008. I joined the club in the AAW at that time, and mostly doing segmented work and things of that nature. So I want to cover here, really the presentation is really just about the design, the build, and the actual turning of these pieces, but I wanted to start first with safety for a few moments. And I try to cover that in everything that I do. And in particular, I'd invite anybody in the audience that if you see something that doesn't quite look right to you, speak up. And either ask me about it or perhaps correct me. Oh, I'll get it behind me. There you go. Good job. And as you do either segmented turning or the staves that we're talking about tonight, probably you'll be working on a table saw. You're doing repetitive work that can sometimes both cause you to kind of lose concentration and or develop fatigue. So be careful with all that kind of stuff. I never recommend anything that I haven't done myself, but at the same time, you should always feel confident in your skill level in anything that you're going to tackle here. On your table saw, got to use mechanical hold downs. I'll show you here, and don't leave scraps laying on your table saw as it's running. They can vibrate over, and it is with a stunning velocity that they can come back and hit you in the face. So I'll just offer you those couple of quick tips. So why on the stave bowl? We've got the stave bowls. I brought some out here to show people on here. And why go to this level of effort? Now, first of all, as we go through here, the first time you make one, it's probably got to make a few new jigs and things like this. Pretty simple after that. You're able to use common hardwoods in lumber form, which are a lot cheaper than blanks and bowls and stuff. For instance, on an ash board, which is pretty common around here, you can get a lot of ash, get an 8-foot board for about $20 at most, and you can make 4 blanks this size or bigger from that one $20 board. So at about $5 a blank, you can do a lot of work here. It also gets you a chance to use a lot of different woods, cherries and oaks and hardwoods and quarter sawn and flat sawn and all kinds of varieties here. And that makes for kind of a good, interesting experience. And you have almost an unlimited opportunity to change the rim and the base to then do a wide variety of activities there. So you get a lot of variety when you're able to make these. Now there are some drawbacks. First of all, cutting these staves accurately so that they will glue up correctly is not difficult once you do it, but you need to take all of the brain work and craftsmanship out of it and make a jig that kind of does it for you automatically. They are also difficult to glue up. I've seen when you make deep bowls like this, you've probably all seen at some time one of these rigs where you've got 2 plates on here and screws and threaded rods and all this stuff bolted together and spinning. And that's actually something to either catch your fingers or your face at about 1,800 times a minute as it spins around and you leaned in too close. So don't want to do any stuff like that. The glue up can also be difficult as you get there. And lastly, the turning, if you will, can be hard on these, even though you have great access to them. They're lightweight, they're not out of balance, all that's really good, but your grain orientation is almost always kind of tough. So, good reasons to build them, but some difficulties, and that's what I'll try to do is take out the difficulties. Now the stave bowls, I started out here, and when I got into this, It was from a discovery on some ash that I had. And so there's two basic designs that you wind up with on all of your ash bowls, or any bowl that's a good American hardwood. You get this pedal-like design by using flat sawn ash wood, and you can repeatedly plan for and produce this thing every time. Now the interesting piece, and I'll show you here in just a second, is the scraps from this bowl made this bowl. And this is the rift sawn edges glued back together. And so both of these are from one about 4.5 foot long piece of ash, 6 inches wide. So about $5 to $10 worth of ash, depending on when you bought it and what store you get it from. And you can see, again, this one I kind of call it like a feather pattern, because you actually have each of the little wedges as 2 wedges glued together. They're kind of flitch matched or book matched as you come around here. And again, you can reliably produce this design. Now here, I put a wooden rim on it to give it some color and contrast. Here I've got a little flat rim that just is just kind of a little bit of a dish to it. And if you leave it, the square edges, and don't hit them with the tool at all, you'll get this pattern that looks like this nice curved edge, but in fact it's actually straight, but you'll get the nice edge on it here. So these are the typical bowls that get me started with the patterns, and then if you switch from one wood to another, you can get a very interesting variety of woods to work on and to build. Now I'm going to set those out of the way, but I brought this one because I did want to donate this one to the Christmas Club. So Clarence or whoever wants to take it, I'll set it over here. So nice. It's kind of a deep bowl. Now this is one of the things you should do, even though this is quote-unquote waterproof with Titebond 3 glue and a good 6 layers of polyurethane finish, I wouldn't dunk it in water.
Can we pass it around?
Yeah, feel free. Well, yeah, there's some more if you need them. Okay, so let's go here and design. Now, first of all, in design, there's 2 real big different pieces to your design. The first aspect is the mechanical design of these. And if we take a look, you're going to really want to wind up building a bowl that probably has the side angle probably between about 30 and 55 degrees here. Now I've got jigs and setups all the way from 15 degrees up to 80 degrees, and the tall ones, you might as well just use straight lumber for that. It's not really worth it. And the past 30 degrees, they get really hard to get a good fit up here. So you pick your side angle first, and then pick a diameter. Now it turns out that in most cases, you're going to want to use either 8 to 10 segments for bowls between about 8 inches and 12 or 14 inches. And if you use a smaller bowl, 8 pieces show up good for displaying the grain. And on the larger bowls, 10 pieces tend to work out pretty well. And so some handy thumb rules for you is that on a 10-segment bowl, your diameter is 3 times your segment width. And for a 8-segment bowl, it's 2.4 times your segment width. So if you want a 9-inch bowl out of a 10 segments, just make it about 3 inches, and it'll come out pretty close to 9 inches. And don't get too worried about that accuracy on that. Now your first step is you want to cut some wedges like this, and you're going to put a square blank on that on a table saw and a jig and cut that off. And so you need to pick that top width, and that's going to wind up being the will make the diameter of your bowl. And then you have to trade off between the length of the piece and the bottom width that comes out. So you want to get your bottom width probably down to around an inch or 2 so that you've got a small foot to it. If you make it bigger, you get a bigger foot. And so what you pick on there, you don't really get an option to change those out. You pick one and the other one is set for you. Now the miter angle is read right off of your table saw miter gauge, and the blade angle is right on your blade tilt. And both of those are the tables I've got here, which, by the way, Jenny is going to be mailing to everybody. I made everybody up a set of angle staves here that you can just read the angles off here and never have to set anything up and plan for it yourself. And that makes it a little easier than doing all the calculations. And here these are set up to 1/10 of a degree, and we're going to use a jig in a second that will show you how that you never have to worry about getting your accurate measurements. To make these actually fit, you need to get to about 3 decimal places, or 1/1000th of an inch or 1/1000th of a degree, and you just can't set that up on your table saw repeatedly. So we're going to make a jig that does that all for you after you do it one time pretty simply. And here you can see you just pick your side angle, how many staves you want, and that tells you how much to crank your blade over and what angle to set the will be cut at. So, and then that's that for that. So that's the design piece for it there, and for the mechanical piece of design. Now when you get into doing that, again, I think I'll try to get these here. I think this shows up pretty well. Get a piece of flat sawn wood like this, which is usually the cheapest lumber you get. You can, I don't think these grains show up too well. Can we switch to the top camera here? Well, yeah, it's not going to show very well, so I'll just hold it out here. Okay. 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 We can see a flower that's flat sawn and centered, and that gives you that pedal-like look when you cut down into those grooves. And a flat sawn board like this that has grain running straight along the edges is easy to go down to the shop and get, either here, Sears, Trostel, any of the places like that. And it's really, the flat sawn wood is the cheapest you get. Now your big advantage here, you're going to set this up in a second and I'll show you how to cut these, is you take these, and I don't know how many people know what a rub joint is, but it's the oldest traditional wood joint there is, but you just put tight bond glue on here, rub this together and hold it for about 30 seconds or so, and you have the makings of a second bowl. So every one of these you cut, you glue the side pieces together, and that will give you another set of segments. And these are going to have the opposite looking grain pattern. So this will give you that kind of that feather look or the vertical stripes to it. And if you go and you move to straight quarter sawn wood, you'll get quarter sawn wood will give you the nice ray patterns like this. And/or this one's leopard wood, and I wanted to pass this one around because since there's no special skill to turn a bowl as light as that one. If that were a solid piece of wood like a turning blank, by the time you got it that thin, if you're a slow turner like me, it starts changing shape on you. You get gouges and cuts and catches, and you break it before you finish it. This is pretty easy to bring a bowl down to that size and weight. Now, typically, I make these flat bowls, but using a 55-degree side, you then can also get a lot of grain pattern for your curly maple like you've got on this. Do a little accents with different purple heart and throw in some turquoise and stuff like that if you want. And then lastly, or not lastly, second to lastly, you also can make the regular kind of traditional vase-like bowl here. All the same jigs will do that. And then finally, if you take one set, cut a set of narrow staves, use their scraps to make a top, then you can also make a nice urn out of it from the same pieces. Again, this top piece is made from the scraps you cut off of this piece. So you get a lot of wood savings if that matters to you, and I do like to try to conserve that. There's wood savings? Wood stavings. Yes, wood stavings. Good. So let's take a look, and the reason I actually, I'll say, kind of volunteered for a session here, let me move this out of the way a little bit, is that I had an article published in last June's American Woodturner on how to build and use this stave, and I had several clubs contact me about would I come and do a demo. Well, I'm not going to drag all this stuff to Cleveland or to Oregon, so I said, well, I should just volunteer for our local club. And that would work out a little bit better, probably. So this is a jig. Let's see if that doesn't fall. Always use the top edge on here. Fits in here. I put some nice extenders on here to make it easy to clamp. You've got some adjusters here, and you just slide this in a groove on your table saw to make it. All adjustable here, and you just cut both sets. Cut one side, flip, cut the other side. And you can repeatedly cut all of the joints, and in segmented turning and in stave turnings, repeatability is more important than precision and accuracy. So if you cut all the pieces exactly the same, you'll manage to get a good glue up when it's all said and done with the way this one particular jig works. So we take here, and let's say we're going to make a 45-degree 8-stave bowl. I just used my regular miter gauge and cut myself a little straight wedge at, in this case, 16.3 degrees. Important, you set that on your miter gauge, cut this piece, flip it, cut the next piece so that you get both pieces the same, check it with the bevel gauge so that it's the same. Then kind of the trick is to use that table and come in and here, cut the blade angle at 15.7 degrees. And then use this to set up your table saw. So you put this in, crank your blade over. This you use to set the 2 wedges here in the middle. And then you cut your first set of wedges. Now, the first set of staves you cut will not fit exactly. They will probably have a 1/8 of an inch gap or a little bit of a tiny gap. If it's on the inside, you must get rid of it. If it's very, very small on the outside of the bowl, you can probably turn it away. So the trick is, you tape your bowl together, test the fit there, and you've got, say, a little bit of a gap on the outside. Change your blade angle just very, very slightly, because you've got 10 times 2 for 2 sides of the board there of the staves there, or 8 times 2, 16 or 20 changes. So if you move your blade 1/1000th of an inch, you got picked up 20 thousandths in the overall fit. So make a small adjustment, and more than likely your first or second time you'll get the blank to fit together perfectly. Then recut this. And then now you have a set that no matter what this angle is correct to make it glue up, and then save it. So I've got one here labeled 8 stave 45 degrees, 10 stave 30 degrees. This is a steep one, 10 stave 75 degrees. And so these things, I just throw them in the shop, make them out of 1/4 inch plywood. And the article here explains a whole much more about how to do it, and I have copies if anybody, I can send somebody a copy if they need it. So you're making the article like that, or making the jig, allows you to safely cut the staves. Now, I had tried some earlier methods, and I'd seen people try to use, like, say, one of the sliding compound miter saws. Difficult to arrange a hold down that will keep the actual stave you're cutting true and not let it wiggle a little bit. And they all have to be exactly the same. The same thing is I had tried some smaller ones where I just used the little metal holders and try to hold it down there. Dangerous. Okay, you get a piece of twist on you, it kicks back. Also, the way this is set up on my saw, and which should be in yours, is the little piece you cut off drops clear and free away from the blade instead of getting trapped under the blade and shooting back at you. So all those safety features are designed into, if you will, this jig. And again, there's an article in American Woodworker about how to make it, and I'm certainly willing to help anybody do that. So before I move off too far here and go to glue one of these things up, or talk about gluing one up, any questions on the basics of how to get your stave sizes and numbers to use, anything like that? If not, we'll call that part good. So you get these things together, and you must always do a test fit up to make sure before you spread some glue on it, because sure enough, if you spread glue on anything, it does not fit when you try it the very first time. And also, if you wind up using masking tape, it falls apart as you attempt to glue it up. You know, the masking tape is just not strong enough on the wooden surfaces here. On a segmented turning where you're banding around the outside, works fine, but it won't hold up. So use either packing tape or even brown paper tape, the old gum type with a wet sponge. You put it on. Either one of those will work just fine. Now here you can see, and can we pick up over here so I don't have to move too far? Okay, I've got some packing tape here, down here, and I've just cut some little wedges out of some scrap wood. And stick these things on. You can put them on with, I use hot melt glue. Takes less than 5 minutes. Okay, I also use CA glue, but CA glue is a lot more expensive than that. But put a dab of CA glue on here, stick those things on there, and even though you would think the strength is not enough, there's 40 of them holding this thing together. Some of these are stuck on the tape, some are stuck on the wood, doesn't matter. Then you just set this thing up, and like I said, we're going to test fit this. Just kind of raise her up here a little bit. I'll put a rubber band so I can put my hose clamps on right quick. Probably should have tightened that hose clamp a little more before we started. Okay, I'm not even going to bother putting the second hose clamp on there. But if you take a look, you can see you've got pretty close to a perfect fit here. And these pieces are straight off of the table saw, cutting all 10 of them at the same time, no sanding, no planing, no adjusting anything. They just came after. Once I made that little tapered jig and put the blade angle on it, every one I cut comes out just perfect like this. But you do need to check, because every once in a while you have set something up wrong. And you do need glue joints about like this. So you take it back apart, butter these joints liberally with Tight Bond, which is the only glue I really use, and let it set for a day, and you've got yourself a blank to work with. And again, you get about, you can get from a 7 or 8 foot board, you can probably get four bowl blanks if you glue them together. So now you've got it glued up, you've cut it accurately, you've glued it accurately, and now you need to mount it so that it'll spin. Because if you get these things, if you, like, for instance, tried to, I was going to say, you got to use the hose clamps. There's no way to press that together because it pancakes on you and goes flat. So you got to use that approach on it. So take this and lay one flat somewhere, and it should sit flat because that's the way you glued it. And you want to take a little bit of time. You can see I've kind of sanded this edge right up here, and by just laying it on my drill press table and with a little sanding disc on the drill press, just raising and lowering it till this piece is parallel. Once this piece is parallel, then all you have to worry about is getting it centered on the lathe axis, and then it will run true. If you get this, say you messed up one of these, or you tried the old method of sanding these to make 2 bad halves and then sand off the middle to glue them together, like sometimes you can do with a segmented ring, well, you've lost a 1/4 inch, an 1/8 inch here, 1/8 inch here on inside and outside. And then you take that and get it a little bit off here, and all of a sudden you have no room to get any curvature in your bowl. And you can only turn a straight bowl if you don't make a good layup here. And here, most of these are pretty flat. I brought this bowl. This is one of the ugliest bowls I've ever made, but this was a 2x6 hemlock scrap at a job site. And so by using a 2x6 instead of lumber, regular 1 inch lumber, you can get a much deeper bowl if you want a deep bowl. So now we're going to mount this thing. We've got a pretty good piece glued up, and I've just got a little wooden plate, and we're going to mount it with a drawbar. And again, a couple of nuts and bolts, a piece of all thread rod. And you can actually, use the bottom of a 4-jaw chuck or anything else that's a flat. All you need is a flat surface. But I've kind of drawn some circles on this one when it was spinning to make it to where I've got a little bit of a guide to help me get it started. We're going to make a mounting for doing an interior mount. Let me get that centered just a little bit. Now people can worry about a 1/4 inch 1/4 by 20 bolt or a 1/4 by 20 all thread, but that will actually hold several thousand pounds of clamping force. Now this is pretty close, and I'll just come in with my tool rest to kind of get an edge to it. Okay. So go from opposite sides, take out about half the distance. Try again. Didn't quite get it. Okay, I got a little bit of a wobble, but not much. It's going to be good enough for here. So tighten this down a little bit. Now, it turns out I'm going to wind up mounting this thing inside on a, I'm going to use a 130 millimeter chuck, which turns out to be pretty nice. You can use smaller ones if you want to. And what I've done is, for all of my chucks, I've got my 2-inch, both tenon and recess mode for the 100 millimeter. This is the 130. So I've got my exact sizes of all my chucks on one little piece that saves time for me. Yes. So all I've done here, like I said, for my regular 50 millimeter chuck, whether it's in a tenon setting or for a recess, the 100 millimeter for tenon and recess, and then for my large chuck, both tenon and recess. So one device has all of my chucks that I can quickly scribe a line to get a fit in there. So I'll give myself a little bit of a mark here. Now then, I use a bedan for this because the bedan turns out to be really handy for all kinds of things. And I come in, and now there can be some slippage on a okay, I can kind of see my line there. And come in just at about 30 degree or 600 RPM or a little bit below, and just kind of gently come in. Okay, now before I take this off, I want to double check that it actually fits. Always a surprise when you have to remount it. And that's going to fit just fine. And here, you're going to be in an expansion mode in the jaws, and the glue is nice and strong, so you just need a bare little 1/8 of an inch or more for your holding on this. Well, I believe you've all had dropsy before. So I come in, my chuck will fit in here. And once again, you're in expansion mode. And so this is a little bit like when Tom Wersing does his platters. And he just has that little small groove on the back because it's in expansion mode. It really doesn't take much of a groove to hold it quite stable for you. Now, if you're doing a deep bowl, your little hex wrench works fine, but if you've got a deep bowl, you may need to cut off an Allen wrench to reach in there because you don't have enough angle for it. Okay. Okay, so you can see you've got a pretty good fit there, pretty well balanced with not a whole lot of trouble to it. And let's see. Now it turns out that you have your grain orientation about the worst you could possibly imagine for all of your turning. You're right on this face piece every time you're coming around. So this is like you're doing faceplate turning, but just on that piece of grain that always tears out. So you've got to kind of work with this a little bit, and each piece of wood will probably behave a little different for you. But basically, you're going to be turning along here as if you're doing a really long, shallow bead in spindle turning. And that's kind of the technique you need to try to remember that you're using here. Is it's almost a spindle turning instead of a bowl turning output, or a bowl turning approach. So what I'm going to do is I'm going to nibble away the outside edge, and I'm going to nibble away the inside edge, kind of cutting towards the end on each one, because that's the way you would naturally be cutting the grain on a spindle if you were turning this. And then at the very end cuts, I will probably go from one direction or the other. We'll cut better, and I'll try to do a final smoothing cut on there, and kind of use a little shear scraping to pick that out. Now for me, I'm going to use the standard Ellsworth gouge. It's a nice beefy thing. These things, you've got these edges coming around that kind of bang in chunks, so we'll make some noise as we do this. The outside is much easier to turn, but I'll use both the shear scraping here, and in general, I try to stick with a gouge and learn to use the tool you've got as compared to keep buying more and more tools. I've also thought on some of these, I've almost thought you could use a skew on these things, or even a spindle gouge, but I've decided just to stick with my traditional bowl gouge here and go for it. So we'll bring this up to about 600. Now you won't get beautiful curls on this. You're going to get chunks and sawdust because you're doing basically face grain turning here. Now right now I'm just doing roughing cutting and just trying to get the wood off here, and I'll try to change to a bevel roughing cut as I actually get my curve refined a little bit. Okay, so let's stop here for a second. Okay, you can see I got getting kind of a good shape. I got some grooves and some machine marks I have in here and stuff. We're going to trim the base in a second, but I'm going to go ahead and address my rim at this point. Now, if you're going to leave a flat rim or a glued-on rim, you want to come in and right in here, take this off and get a nice smooth edge, at least partway in, while it's still in this orientation before you flip it around. If you flip the bowl after you've got it down to time and then try to take off this rim, it'll vibrate on you, bounce around a little bit, and so just now's the time to do that. If you want to try for one of the scallop type edges, just leave these straight and it'll come out just fine. So I'm going to change the tool rest here just a little bit, and I'm going to take this edge off. And again, it'll be a little noisy. Now I'll take the rest of those off when we're on the inside, but this gives, oops, I didn't quite get that all. Well, it's good enough. Okay. Okay, so now I'm going to try to do a couple little smoothing cuts here. And this is the part where I said to watch out. Instead of a concert, you're liable to get a harmonica or accordion thing here. Here, you want to kind of come in, start your cut with your handle almost horizontal. As you get into your cut, roll a little bit so you've got that nice bevel rubbing cut right across the top, and then try to hold your steady line all the way through. Now, you may come in and see that it just gets too rough because you're actually cutting uphill grain on this first part of it. If that's the case, I'll try to cut it from both directions, and then I'll come back and smooth it a little bit. But let's see if I can get her going a little bit. And again, you want to keep in to hold your bevel rubbing cut. You keep your handle up here, and you're constantly, as you come across, you're changing to keep so you stay in the cut there. I'm going to take this piece out a little bit first here. I'm going to make a flat for my Okay, not too bad there. I've got some more grooves and machine marks which are a little rough there, a little rougher than they should be, but in interest of time, I'm going to take those out with some shear scraping rather than trying to get them turned down perfectly. Yes.
You know, not everyone's probably familiar with how you shear scrape. How you hold it.
Sure thing. Now, normally, when you shear scrape, like if you're watching David Ellsworth, he will shear scrape in an angle like this, and that seems to be too steep for this particular orientation of the wood. So I'm kind of shear scraping straight across, and I do have some tear out up here that is a little more than you should be, but you're getting down to a fairly good surface. You can see these grooves we have right in here. those need to come out because you'll sand a long time if you try to get those out. And on these turnings, unfortunately, you're always going to have to sand on these. You know, spindle turning, guys, you can come down to 220 or 320 to start your sanding. You'll probably have to start sanding at least at 150 grit on these. And it's just because you're in a face turning orientation. Let me straighten this out a little bit more and get started on my bottom. And here, on this one, like I said, I'm coming in, keeping that top edge about 1/16 of an inch there, and that bottom edge just barely touching there. I'm going to actually try to come at it from this direction and see if I can get a little smoother cut. And also, if you're getting a smooth cut, you can also try either getting slightly above center, or, in fact, I should probably do that right now. I should probably get a little closer to on center, is about usually where I turn these. And that might have been a little high on that one, or low was that. So adjusting your height when you're doing these is also one way if you're having trouble getting it to cut smoothly. Okay, so I've got my lumps and bumps in here. This surface is still a little rough, but I can wind up spending quite a bit of time because I'm a slow turner at this. And so rather than spend a bunch of time trying to get this smooth, I'll assume all of you could probably get it a little smoother than this before you got into sanding. So I'm going to come across here and I got to do two things for my base. And knead it flat. Okay. I'm going to go back to the Badan, and you always need a little bit of a socket on these things. So your bowl is coming over like this, your sides are like this, and your base needs to come up, go into it and come down, and you have a corresponding piece like this. So you'd like to get it, two things, is both the glue surface across here and across here at least 1/4 of an inch. 3/8 is nice, and how thick it is will also determine how thin your bowl needs to be at the bottom. But you do need some kind of a little step joint like that, and when we get to turning that in a second, I'll show you. We're going to get ready for it here right now. So I think this actually tool rest will work fine. Okay, so now I've made myself about 1/4 inch or so recess. I might try to get that a little bit. That's good enough. And a flat piece here. And usually I'll glue these with Tight Bond because Tight Bond has good shock resistance if you get a catch or something like this. We're going to glue this one with CA glue, and I've done dozens of these with CA glue, and it holds up just fine. Some people worry about it not being archival and so on. I've got bowls 2 or 3 years old, 4 or 5 years old in some cases, and the CA glue has held up just fine. So we're going to use that in here and try to get as square as I could in here, and I'll take a little quick hit with a sandpaper to make sure the bottom is actually flat. And so now I've got myself a nice tenon to use for, whoops, where is the stop on this? This one? This one? Oh, I see it now. It says lock. I bet that part would really work well. So now I'm going to fit up my base, and we'll talk about bases for just a second. And we're going to be able to put this on and glue it and flip it and do it in probably a total of 5 minutes or so. So I think we'll have plenty of time for that. Set this up here for now. And on your bases, 2 things are kind of important. One is don't use just a flat piece of wood if you can help it. The flat piece of wood will glue up just fine, but it won't. With it as it ages, the flat piece of wood, especially if the bowls are thin, it will warp a little bit and the bowls will rock on you. At the same time, they also don't provide anything in terms of artistic interest at the bottom of the bowl. So if you use like a little piece, just a 4-piece wood block that you've cut out of a say a 10-inch long section here, get a nice pattern of some type for the bottom of the bowl. And also, if you like differently, you can also use, and I'll pass this one around, you can make a nice little diamond pattern like this with multi-segments. I think this is looks like 10 pieces. It gives you both visual interest here and also around the edge here. So always making up some kind of a little detail for the foot is kind of nice. I'll pass this one around just to take a look at it. And when I make these, I dish it while it's still on the chuck here, just to make it a little easier on the turning. So when I put this in, I'm going to intentionally unlock it. Normally, I would actually have my jaws come a little closer together than we have right here, but I've got it a little bit open on purpose because once we glue it in, I want to true it up to the way it actually glues up at the very end. So let's come in, and I've got a variety of tools here. But we're going to smooth the bottom and then bring it down to about the right diameter. So now, I'm sure all of you always turn off the lathe every time you move the tool rest at home. I do it here for safety because you should, but I will admit that I don't always do it at home. So here I'm only going to need about 1/4 of an inch down. Let me stop and get my measurement here. A little bit of depth gauge to get the right depth of the socket. I've got one of the Laguna lathes, and this one has a much lower tool rest when it's all the way down to the bottom, and you can really tell the difference. That bold gouge just comes a little easier for coming across it with that much wood to come off. But a banan would work just as fine. I will chew it up with the banan. Now, another good reason to have a pretty good size base here is that if you foul it up, you can just cut it off and move in again. But I'm sure nobody else has ever done that. Need to be a little closer. Okay, just about right. All right, take another cut across here. Just give myself a little bit of a taper coming in. Okay, and then with any luck at all, I'm still a little bit too big on this. Not much. I don't know about anybody else, but when I'm in the shop alone, I can take 10 or 15 tries to get it to fit, and then the last cut's a little too big. Pretty darn good. I'm going to just come out just a tiny, tiny bit. Famous last words. But what I'm going to do, just do a little bit of that. Okay. Oh, that's going to be just about right. Now, probably don't have quite, let me see. I got a little bit of a hump on that, so I'm going to take that out too. Now, occasionally, I'll cut one of these with a little bit of a taper this way or too small, and instead of giving up and starting over, I'll use colored epoxy, either black or red, and glue it in with epoxy, and it gives you a nice little decorative ring, and then I act like I had planned it that way. Okay, I think we got that there. Yeah.
From Zoom is how do you add a contrasting rim on when you do your golf?
Well, we'll show you in just half a second, but basically, this is a rim that I've made up from another turning, and I just save them when I'm done. We'll cut this off square and flat and flush, use the sander on it to make sure this is flat, glue this on, then turn the rim off. So it's just like a regular segmented turning in that case. So we'll just use it like that. Does that get it? Okay, so let's put this back on. Now, most people probably have invested in one of these centering Morse tapers, and if you haven't, they are a huge time saver compared to making up a bunch of jam chucks all the time, and they're pretty handy. Okay, double check that fits good. Looks pretty good. It's just a centering, I don't know if they call it a centering chuck. It's an alignment tool, and all it is it's the same size as your Morse taper on your lathe, and with the same size adapter as the spindle, and they cost about $30. So both craft supplies, Woodcraft here sell them, and they really are handy for anything you want to do. And so we're going to come in. I'm going to use CA glue on this. And we're just going to liberally dose it up. Now we're going to have to let that sit for about 5 minutes before we reverse it, and actually probably not even a full 5 minutes. So we now have this foot. I'm going to take this foot off and take it off the chuck, bring it in with the back tailstock support, retrue this ring, and then when I turn this around and flip it on the lathe, this rim should run perfectly true. So this will be your next test, or my next test. Let that set a little bit. Any questions so far while we let this set up for a second or two? Does anybody else know the actual correct name for this? I always just... Okay, a reverse chucking alignment adapter. There you go. Okay. Now if something is got a piece sticking pretty far out from this end, and even though that held it pretty close in alignment, you could have just a little bit of variation here. So we're going to go ahead and kind of just retrim or cut that final groove there. And we'll bring in the chuck just to put some tailstock support on it so there's no wobble when we cut it. And this is the time well, maybe that other one's going to be the best bet after all. Okay. And I've got a homemade dovetailing tool, just a cheap, picked up a pile of tools from a garage sale one time and just some old skews and just ground off the edge where it's the same angles as my dovetail jaws, and just give a little cut to make sure it's nice, it runs nice and true. Should be good. What's my time check here?
You have about 40 minutes.
Oh, good. Some chance we'll make it. Now this method of mounting on the inside for a bowl like this, as far as I know, the only guy I see doing that is Richard Raffin. I see he's done that a lot. But even on your twice-turned bowls, boy, it is a great way to hold an out-of-shape bowl. You're in expansion mode. It holds it rock solid, and it's much better than pushing something like you put a friction disc here and you put tailstock pressure on to kind of center it there, and it's all kind of wobbly and turning and stuff, and you can't really get to the base to turn it. If you do this same mounting arrangement with a rough turn bowl, you can get your base just really nice, good access to it. So I really kind of recommend that as a handy way to mount any bowl that you can. You're going to be turning the outside. I think we should probably put this in the okay, so let's give that a little spin. And you see, don't get confused between the two, but there's these points out here are wobbling, but this rim is running just perfectly true here. And so that's kind of a nice way to start that. Okay, so in cutting this, on your inside turning, you have again the same basic problem that you've got a bad grain orientation. And here, you're basically, as you come in this way, the way you would normally turn a bowl, you're doing end grain hollowing. You're going straight into the end grain all the way, and there's a lot of heat and noise and friction and dulling of tools as you try to do that. So instead, I'm going to nibble away the outside, just coming like I was kind of nibbling before. Do that, and I'll smooth it and get bevel rubbing cuts and kind of come back in and just kind of scoop the whole thing out as if I were doing a hollow form almost. And I was using a set of tools inside there. And then I'll clean them up with some more shear scraping and so on there. So for me, your natural tendency is want to go in and turn them this way. You can't get a good cut that way because you're going to be going against the end grain all the way. So we'll try that. And what I'll do is about every 2 inches or every 1.5 inches, 2 inches, I'll stop and kind of smooth it out. Because once you get the rim thin, if you go all the way in and then you try to come back out and smooth things, then it's going to start vibrating on you. And also on these, this is birch, so I don't think it's going to be too bad. If you're doing like hard maple, you can really get these things to sing. I mean, they can really get a high-pitched whine. And if you start getting a resonant chatter-like whine, quit right there. It's going to hold together, but you're going to get grooves in it and little chatter marks that you just can't get out. And I may have to take that. Yeah, I'm going to have to take that tailstock off. Okay. I was telling Chris, I think I've got a homemade swing away from my lathe at home, which cost me almost $12 to make, and it's the handiest thing I've got. Okay. Okay, so I'm going to spin this up a little bit to make sure that everything looks fine. And because this is a pretty good diameter, it's only going to need to be about 500 or 600 RPM, about 600 it looks like. Okay, I need to come a little further away. And I'm going to start these peeling cuts here. Remember, I've got a nice groove in there. I'm going to start taking off this edge. Okay, so right now this edge is almost flat, which is usually not a decorative edge. People like to get a little bit of character at that. But if I were going to do a added ring, then I would trim. This is a little out of round here, not quite flat. I'd sand it flat, make sure my ring was flat, and then I'd glue my ring on and wait the appropriate time. If again with these thin vessels, you can do this with CA glue and work them in 5 or 10 minutes later. And then I could give a nice ring, and you can put any kind of edge treatment you want, whether you want it scalloped, flat, standing, however you want to go there. So I'll come here. I'm going to do, and I will also caution you that that edge right there will cut you like you wouldn't believe. So careful for that. So now I'm going to just go ahead and just kind of keep doing the same thing, trying to do as much of a close to a bevel rubbing cut as I can get and go all the way in, but about every 2 inches or so or 1.5 inches, I'll stop and smooth it out. Okay. Now, normally, go ahead.
Got a couple of questions.
Yes.
Where's the microphone?
Oh,
Okay. We got a couple of questions.
Sure.
One was about the adapter you use.
yes.
Somebody said that they heard it's not for use with the lathe turned on. Is that correct?
All right. These are strictly a holding piece. They are not to be used with the lathe turned on. This is a regular steel Morse taper, but this piece is aluminum, and it's just a press fit on there. So never use these to spin the piece. It's just an alignment tool. Good question.
Okay. The other question is, someone asked if a carbide cup cutter like the Hunter Jimmy Clues one would be one way to hollow this.
I have a cup cutter. I have not tried it on these. And the reason I haven't is that I've never been successful using it on a regular hollow form. I've never been able to use that at whatever the correct angle is. I've not found it. So so I have one if anybody would like one. So I've not been able to do that. You can use the carbide cutters like the Easy Tool or the Easy Wood tools. Those will cut these pretty good. Now they bounce a lot when you've got all the segments in there, but once you get them smooth, they'll cut pretty close to as good as a regular chisel. They give a little rougher surface, but again, you're going to sand these no matter what.
Okay, one more question.
You bet.
So you've got that real deep stave bowl.
Yes.
How do you do that without doing all end grain cuts?
Same exact thing. I actually do it just exactly like this, only I used a 2x6 to make it instead of a 1x. Oh, this one. Oh, I actually just hollow that out with my regular. I've got one of the Carter and Sons hollow, or not Carter and Sons, but Carter tools, the Hollow Master with the deal. So I just actually do this just as a hollow form. And what's nice about that, if you've been trying hollowing and haven't been successful for it, if you do an open form but use your hollowing tools, you can see how they're working and really learn how to use them. So I actually do these on a regular, that little small bit that sticks out, scoop them right out. And I suppose you could do that here, but you do get a rougher surface. Now, anything else?
Little less than 30 minutes.
Okay, we're going to be on about time.
The other one said was, could you use a bottom gouge with a steep bevel as the way to do it?
Yeah, I've tried a variety of gouges, and I didn't bring one, but I do have the standard, the traditional, I'll call it bowl gouge with the 45 degree and just the square cut. And I've been fairly good, but I've not been as good as I've been using this. Okay. Now for me, I never use those fancy calipers that you can buy to measure the wall thickness. I just feel it. And so I've got this I got about the right thickness now, and I was going to leave this square so you can see how my rim would glue on if I were to stop and glue a rim on. But I'm just going to go ahead and bring this down and start bringing this the rest of the way down, trying to keep my thickness through here and keep it smooth as I go. And I've already made most of my excuses, but I'll repeat again that I tend to be a very slow turner. And so for me, I just I won't be able to get as good an edge as I would at home, but you also don't have to watch for 6 hours, so there's a bit of an advantage. Okay. Now, if you can stand all the way at the end of the lathe and bring this down, which would ruin our camera setup, it's really much easier to do this from dead end on the lathe. Now I'm going to put a little bit of a dip in my bowl rim here. Okay. So I did that little bit of in-grain hollowing. You can see the surface that it left you here. Really chipped out bad. A little bit of shear scraping. Okay, now I'm going to take the next segment down. I'm going to shut it off to feel there because this edge is really sharp, and if I reach my hand in there to feel my depth, I'll wind up cutting my palm pretty good. Yeah, I'll be okay. Now I'm going to switch, and I got to get a little bit smaller gouge in here because I'm getting down into the curved part here, and I need to straighten up this. I've got a bad edge right here, so I'm going to connect that, correct that while I can, and then we're going to move into the last piece. Now, if you remember, I had that little step joint right at the bottom, and however thick we were going to be right there is going to determine how far I have to cut in here. So now I'm going to come in, I'm going to go ahead and start at this edge and find that edge of the foot that we glued in. You can see I've got it pretty smooth right here. I've got a little bit of a lump right here I want to take out. And again, this is a little rougher than you would like to start sanding. This was I got actually a couple of good dips in there, but I think as far as demonstration purposes, this will be close enough for tonight. But let me get this one little piece out here. And also notice I'm turning this at about 1,000 RPM, which for a 10 plus inch bowl is a pretty good speed. So it's lightweight, they stay well and balanced. Now I'm going to add a little bit of a fat spot right here. Okay, so now I'm going to try to find that center. Now for me, I almost always have to use a scraper to get that little dimple out of the bottom here. Well, I've got a couple more ridges and dimples and pieces than I really wish I had in here. A little bit of waviness to it, but all in all, not bad. And you can see that you do get a kind of a nice pattern here at the bottom, as well as the rays going around here. And then we'll just come in and we'll try to finish up the foot right quick. And then we'll be done.
About 15.
15. We should be right on track. And I did bring a spindle gouge with me because this piece you can turn strictly as a spindle gouge piece if you want. The small bowl gouge works just about as well. And I'm not going to try to do too fancy of a job on this. It's little pieces of CA glue. Okay, so I've got a little more touch-up work I need to do on that. Switch to a spindle gouge and see what I can do. Okay, so I tried to give myself just a real delicate little foot down here at the bottom. Kind of chipped the edges a little bit, but it would sand out a little bit, and you can see it, just barely see the bottom piece there, but in the front, I'm going to take it off here. Now I'll leave it in this set of jaws until I sand the outside. You can kind of see you got a nice little pattern in the bottom here. Once you put either some shellac or something to pick up the grain, then sand the shellac off, dye it, whatever. Even though it's a pretty plain piece of wood, this was some of my first experiments with birch. I had not done this with birch before. I've got a few ripples and dents that I wish I didn't have, but trying to do it all in all, not too bad. Probably should have put either a little more dish to the rim or made it a flat glue-on rim, but all in all, that's pretty much how you make one of these. Any last questions?
How would you part the bottom off?
Oh, what I'll do is I will actually reverse mount this to a vacuum chuck, pull this piece off, and then just part the bottom off. Or you could put it onto jam chuck or Longworth jaws, cold jaws, any kind of way to hold it. But I'll usually leave this piece on until the very end and use it as the centering jig to whatever I ultimately turn it off on. And if you want it, if you've got like a power small orbital sander or a random orbit sander, you can cut it off now if you want to and do that. But I prefer to leave it for sanding and finishing and dyeing and anything else you're going to do to it.